Today, we'll be looking at sequence part 2. We'll be looking at the sequence part 2, right? We've just done part 1. We've taken a look at part 1, arithmetic sequence. In this one, we'll be looking at the quadratic sequence. And part 2, we'll be looking at quadratic sequence and cubic sequence. But before we do quadratic sequence, let's quickly take a look at linear sequence once again. A linear sequence, like arithmetic sequence, has this, the end term of a linear sequence is an plus b. The end term of a linear sequence is an plus b. So the end term of a linear sequence is, please take note of that, an plus b. Okay, is equals to an plus b. Now, what about quadratic sequence? What about the quadratic sequence? How do we write the function for the quadratic sequence? For a quadratic sequence, we have the end term is given as an square plus bn plus c. An square plus bn plus c. Okay, n is used as x. You know, in quadratic we always write x, right? The n here is used as x. Okay, same thing. This is the function for quadratic sequence. Now for cubic sequence, let's write the function as well. For cubic sequence, the function is, you should know how to write these ones, okay? An cube, cubic sequence means power 3. An cube plus bn square plus bn square plus cn plus cn plus d. Okay, d is the constant for cubic sequence. So you can see we have 4 parameters in cubic sequence. We have a, we have b, we have c, and we have d. So that we're going to look for. Now let's take a look at one example. Imagine we give you this sequence. Imagine we have this sequence 4, 7, 10, 13, and this is an arithmetic sequence. Let's make a table. The first thing we do, we make a table. We call this position 4, position 1, 7, position 2. Look at it, 7 in our sequence here is position 2. 10 is position 3. 10 is position 3. 13 is position 4. 16 is position 5. You can see all of them, right? So we make a table like this, and then we extend our table. We find that we say first difference. We extend the table, same table, we just add to the table. The same table, we just add to it. We draw a column, we draw a row. Okay, I say a column, a row. You draw a row and to add to it. You say first difference. You write first difference here. Okay, this is what is written here. We write first difference. What do you mean by first difference? You say 7 minus 4, you get 3. 10 minus 7, you get 3. 13 minus 10, you get 3. 16 minus 30, you get 3. So the difference is all same. So it's a linear sequence. This is not a cubic sequence. So if it's a linear sequence, remember the function, it will be, the end term will be what? An plus b. An plus b. This will be the end term of the sequence. An plus b. So we're going to draw another table to make comparison. We call it comparison table. We're going to make another table to make comparison. Okay, this table, what we do, we draw position 1, 2, 3, 4, 5, and then the first position, n is 1. So you begin to put, in place of n, you put 1 here. You are using this function. We're going to use this function. In place of n, for position 1, n is 1. So 1 times a is a. I write the a down. There plus b. So it becomes, this place becomes a plus b straight away. This place becomes a plus b straight away. So here becomes a plus b. Now I come back to this function. For position 2, my n is 2. So I'll say 2 times a, I get 2a. That's how I got 2a here. And then plus b. The b is a constant, so you just say plus b. Now for position 3, n is what? N is 3. So I'll say 3 times A, I get 3A. That's how I got this 3A plus B. B is a constant. For position 4, N is 4. 4 times A, I get 4A plus B. For position 5, N is 5. So I say 5 times A, I get 5A plus B. So this is what I get for all of this. Now I find the difference. The difference between the whole of this one at position 2 and the whole of this one at position 1. Okay, the difference is that 2A minus A, you know, we subtract second minus first. 2A minus A, I get A. B minus B, B in the second position minus B in the first position is 0. So I get only A. Same I do similarly, same I do here. Right? Same I do here. I'll say 3A minus 2A, I get A. 3A minus 2A, I get A. And this B here minus this B here minus this B here equal to 0. So no need to write 0. So here I do same thing. I say 4A minus 3A, I get A. This B minus this B, I get 0. So this one 5A minus 4A, I get A. So you can see all same common difference because it's a linear function, and linear sequence. So what we have is here, whatever is here is equal to whatever is here. Whatever is here, this place, is equal to whatever is here. So A equal to 3. So A equal to 3. We need to find A and B. We need to find what? We need to find A and B. We need to find A and B. So this, we make comparison. It's called comparison table. We're going to compare, right? We're going to compare the two tables. So we compare the first table and this new table we just created. So this one here is equivalent to this one. So we just say A equal to 3. A equal to 3. Now we found A equal to 3. And then we say the next is A plus B. Whatever is here is equal to whatever is here. Whatever is here, this, because 10, look at it, 10. This location is same as this location. So you say A plus B equal to 4. So I write that equation like A plus B equal to 4. Okay, equal to 4. Now remember, A is already 3. You already found A to be 3, right? We're going to substitute 3 for A. So I'll say 3 plus B equal to 4. 3 plus B equal to 4. So B will be 4 minus 3. You bring 3 to the other side to meet 4. B becomes 4 minus 3. 4 minus 3 equal to 1. So B is 1. So our B is equal to 1. Now you know B equal to 1. You come back to the original function. A is what? A is 3. So we say you substitute A and B in this function. So our n term, you remember that's the n term formula. So we write our n term. Now we write our n term. Our n term is equal to A. Remember A is what? 3. So we write 3 times n, 3n. So I get 3n. I say 3n and B is 1. So I say 3n plus 1. So you can see we get the sequence. But the previous way was faster. Let me show you the previous way, why you don't have to go this Makkah and Medina before you get to where you're going. Now I show you. The previous way we just say find the common difference. And the common difference is 3. We say take 3 to multiply 1. 3 times 1 is 3. So what makes it 4 if I add 1? So it becomes 3 times 1 plus 1. 3 times 1 plus 1, we make it equivalent to the first term. So 3 times 1, which is 3, plus 1, we make it what? We make it equivalent to 4. We make it 4. So you come here, you write n here. Remember, the previous way is faster way. In the exam hall, okay, but this one is only for linear sequence. This previous way only for linear sequence, not for quadratic that we're about to do after this. Okay, now you come here, you say the n term will be what? 3 times n, so I write 3n. Then you say plus 1. 3n plus 1. You see, I don't have to do all I did just now. So I get the n term. All we did just now is just to find the n times 3n plus 1. But what we did all this one we did, created this table, a minus b, blah, 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 all was just to be able to find 3n plus 1. And I've showed you the fastest way to do it if it's a linear or arithmetic sequence. Fastest way is just to take the common difference, multiply by this, and check whatever it is, what will make it to be this. If it's to subtract, you subtract. If it's to add, you add. And once you get that logic, you use that common difference to multiply n. Then you add whatever you added to make it 4. You add that same thing because it was 1 we added. So you add that same one, you get the n term of the sequence. Now let's go to the geometric sequence. In geometric sequence, we're going to now we're giving this function. Look at it, we're giving this function. Or we're giving this sequence. The first thing to do, we put it in a table. Okay, 0 will be position 1. See the 0, see the 7, see the 18. CD33, CD52. This is the sequence we are giving. We put them in position 1, position 2, position 3, position 4, position. Put them in position. The next thing we do first difference. What do you mean by first difference? 7 minus 0, second term minus first term. 7 minus 0, we get 7. Okay, that's how we got the first position. Now let's move ahead quickly. That's how we got this one. Oh, okay. Let's take another color because the color is obviously this. So we say 7 minus 0, we get this first difference. 18 minus 7, we get 11 as this difference. You can see the difference are not same. Once the difference are not same, then you don't have arithmetic sequence. Now you say 33 minus 18, you get 15. You say 52 minus 33, you get 19. The difference are not same. If they are not same, we do another level difference. We do what we call common difference. We find common difference to see whether in the common difference we will get the same thing. We do the common difference. If the difference are not same, we do the common difference to see whether we will get the same thing. Now we say, you see, just now, the first difference, we have the second one of the first difference is 11. So you say 11 minus 7, you get 4. You say 15 minus 7, minus 11, you get 4. 19 minus 15, you get 4. Now at the second level difference, you have the same difference. Now we have same difference, then we know it's a quadratic. If you stop at second level, it's a quadratic. If you reach third level, it's cubic. If the difference is at second level, it's stop and it's same. So we're going to make a table to compare with this. We're going to make this big table to compare with this. Now in the exam, here is where I say I have a trick. We don't have to do what we did in the previous video on sequence. Now what is the trick? Remember I've given you this function for cubic sequence, for quadratic sequence. I say quadratic sequence is an squared plus bn plus c at the beginning of this section. Okay, we've given you the function that you're going to follow. Now what we do, we write position 1, position 2, position 3, position 4. When at position 1, n is 1. Okay, at position 1, n is 1. At position 2, n is 2. So n is 1. 1 square is 1. 1 times a, I get this a. I get this a. So b times 1, n is 1. b times 1, I get this b. C is a constant, you just write the c. So I get a, in this place, I get a plus b, term 1, for term 1, because I'm creating this table to compare with this one. So for term 1, I'm going to have a plus b plus c. Now here, n, position 2, you put 2 in place of n. 2 squared is 4, 4 times a, that's how I got 4a here. 2 times b, 2 times this one, we get, you say 2 times n, you say 2 times b, sorry, you get 2b. And then c is constant, right? This. Now we only do for 3. For this one, we do for 3, we stop. N is 3, position 3. 3 square is 9. 9 times a, I get 9a. 9 times 3 times position 3. 3 times b, we get 3b. And c is a constant, you just write it. So you can stop here. Okay, you don't have to finish all of them. You don't need all of them. So the first 2 or first 3 is enough for the beginning. Then what will you do? What we just need is to find at this level, you subtract this to find the difference, first level difference, you write first level difference, just like you did here, just like you have first level difference. This one we just did for the term. This one you just did this for the term. Then you find first level difference. For first level difference, you just say what you do is, okay, what I say you should memorize so that you don't have to do all this table. The short way, I'm going to show you after this. Okay? Because you don't have to memorize, trust me. You just need to write this one, and this one down for quadratic. All quadratic, you're going to need these 3 things only. all quadratic. You don't need to do the whole table. Memorize this. This is what we tell some students. Memorize these three things. You know the first level is A plus B plus C. Second level, and the term is A plus B plus C. First level difference is 3A plus B. And the second level is 2A. That's it. Just memorize this one. You do this table only. Don't do this big table. Yes, I'm telling you this trick now because previously we were wondering how they will give something so long for 3 marks and it takes students more than 5 to 10 minutes to solve. Now I found a trick where you don't have to spend all the time. You can finish in 2 minutes. Once you do this level difference, once you do this table, you don't need to do this big table that will waste your time. How? You just need to memorize that the second level is 2A. So you say 2A equal to 4. So you just say 2A equal to 4, right? Now let's say, take a look at it. 2A equal to 4 and A equal to 4 divided by 2. 4 divided by 2 is 2, so A is 2. So if 2A is 4, A is equal to 2. So you found your A for the quadratic. You don't need to do this table anymore. I'm telling you the secret to pass. For any quadratic sequence, you just need to do this one. You know this one you have to do. First level and second level. Once it stops at second level, you already know it's quadratic. Then, for the quadratic, you need to know the upper level is A plus B plus C. The middle one is 3A plus B. And the last one is 2A. So if you like, write them down. Please write this one down, which is very important. The first one, which is the term, is A plus B plus C. This one you must memorize if you don't want to do the table. Because if you don't memorize this, you must do the table. Then the second, which is first difference, is 3A plus B for quadratic. 3A plus B. 3A plus B. And then the last one is just 2A. So which is second level difference. So once you know this one, once you know this, you don't need to memorize, put it in your brain. This is for term. This is the position of term, which is this place, term, this place. First level difference is 7 here, which is this. You're going to equate 3A plus B equal to 7. And then second level difference, which is 4, is what we equate 2A to. That's what we did just now. We say 2A equal to 4, this place, the bottom one. So once you memorize this 3 level, finish. This is the only table you need. With this one will not take you 2 minutes. This one will not take you 2 minutes. Okay? This is 1 minute table. And then you memorize this for quadratic. For cubic, there's other one you go to memorize. But this is for quadratic. Then, we already found A. Now, let's find B. To find B, follow 3A plus B. Follow this place, 3A plus B. 3A plus B is equal to what? You go to the corresponding position, first level difference. 3A plus B is first level difference, which is 7. See? Which is 7. You go to say equal to 7. You just say 3A plus B equal to 7. Please pay attention. I'm giving you a trick. So A, we already calculated A. A was 2, right? So 2 times 3, we get 6 here. Don't ask how we got 6. We already calculated A when we use this one just now. We say 2A equal to 4, A equal to 2. So 2 times 3, we get 6. Then plus B, 6 plus B equal to 7. We're going to look for B, right? Equal to 7. So B will be 7 minus 6. B, you bring 6 this way. B will be 7 minus 6. So B equal to 1. So I just go straight. I say B equal to 1. So B is 1. You found B. Now we're going to find C by saying A plus B plus C equal to what? Equal to 0. Look at the position for C. Okay? So you're going to say A plus B plus C. Remember you found A already, you found B already. It's C we're looking for now. So you say A plus B plus C. A plus B plus C is equal to 0, right? Equal to 0. Let's see the comparison. Yeah, equal to 0. This place is for term. This place is for first level difference. And this place is for second level difference. This place is for the second level difference. Okay, so A plus B plus equal to 0. So A is what? 2. B is what? 1. Then you say plus C. Plus C equal to 0. Equal to 0. So this plus this is 3. So 3 plus c equal to 0. 3 plus c equal to 0. So you move 3 to the left side, to the right side. It becomes negative 3. So c equal to negative 3. When this 3 come here, c becomes negative 3. Now you found a, b, c, you substitute them into the general formula. You must remember when you solve this, you must know the general formula. This is where the whole story starts. We're going to substitute them into the general formula. What did we get for a? A was 2. So I write, so we can write under it, right? We say a 2n squared. We say 2n squared. Only a, b, c you substitute, right? This time around. Then b was what? B was 1, right? So b was 1. So you just say, no need to write 1n. Just say plus n. No need to say 1n. Just say plus n. And then c was minus 3. You say minus 3. This is the nth term of the sequence. So you can come and write anywhere you like. The nth term of the sequence will be what? See, look at it. 2n squared plus n minus 3. That's it. That's the nth term of the sequence. So you don't need to, this is the one that wastes time doing this table. Now I'm telling you, I have a trick. You don't need to do this table anymore. You just need to memorize that the position, the term is a plus b plus c. The location for term, you write a plus b plus c. First level difference 3a plus b, you need to memorize it. And second level difference is 2a. So you start from the bottom. When you start solving, because this one has only one variable. Why did we not say a plus b plus equal to 0? Why did we not solve this one first? Because you have 3 unknown, you cannot solve this one first. You have 3 unknown, you cannot solve this one. Why did we not solve this one first? You have 2 unknown. In a function, when there are 2 unknown, you cannot solve first, except you are doing simultaneous equation. So this one, you have only one unknown, which is a. So if you wonder why I start from the bottom, 2a equal to 4. Then you divide both sides by 2, you get a equal to 2. That's why I started from the bottom. Then you start from the bottom to the top. That's what we do. That's what you do. You should do here. Start from the bottom to the top. Why? Because the bottom is one variable. After you get this variable, you substitute here. Then only one variable you are looking for now when you equate to 7. So then you do this one. And then after you get this variable and this variable, you substitute them here. You are now looking for c as a variable. When you equate to 0, you'll be able to 0 position. You'll be able to solve it. Is that okay? So that's it. You just need to memorize it. You don't need to do this whole table. Please, it's a secret. Okay? It's a trick and a secret that I've just shared with you. So with this, we come to the end of this section. The cubic sequence we do in our part 3. Thank you for joining us. Thank you.